or two. Yeah.
All right, we're gonna get started. So, sprint one happened. I think as of 10:30, every single team and just about every single member in a peer programming or otherwise channel. That's the last that I was able to pay attention to it. So I want to let people know that for sprint two, I was paying attention to a lot of what happened on Discord throughout the sprint. And asserting myself where necessary, but really there wasn't a ton of place where I felt like that needed to happen. I think there was a lot of work being done and that work was pretty visible. There obviously are concerns on a person-to-person basis about who's contributing, et cetera, that will show up in peer reviews. We'll continue to reach out to people where I feel like that is necessary. But in general, I think people should be very proud of the work that was done. I think we have a lot of learning happening in this class, and a lot of the outcomes from this are difficult. They're difficult outcomes to learn and be a part of. They're not happy, they're not easy. Learning to deal with other people, learning how to work together and in a efficient and official setting, both of those. But yeah, there's a lot of learning that I see happening, which is good. It just so happens that a lot of that learning is frustrating, which is part of the process, I think. It's necessary, it's a necessary evil for figuring out how to move forward and interface with this career. So I did want to say that. I do want to check in though with every group, just kind of on a group by group basis. If you have issues with individual members of your team, please save those for peer reviews or individual meetings with me. But I'd like to meet with each group. If any of you have time after this class, I'd love to have a quick check-in. The questions I would ask you are something like, on a scale of 1 to 10, how efficient do you feel like you were as a team? Do you feel like you all worked well together? Do you feel like you were able to do your best to create the best program that you could for this sprint one? And if that's the case, good. And then just hearing your feedback about how did that go? If the rating is lower than a 10, maybe that's a group discussion that we can all have, just so that I check in with you. I know how each of your groups are doing on more than what gets posted on Discord. So looking back on it and thinking about how things went basis. So I'd like to ask that. That's kind of just the kind of check-in that I'd like to do. And I will also get sprint 2 up and published, although I think we will be disappointed about the amount of new information that you will get from that document. We got just about everything that we needed from the client with regards to the functionality of what we're looking for sprint 2. So to summarize what the client wanted, we need some kind of graphical user interface. We need some way to visualize these classes that we are creating, the relationships between those classes, the fields and methods and parameters within those. So just some kind of graphical representation. We need some way to launch the application in either command line mode or graphical mode. We are not scrapping the command line. That is something that we want to continue to support and develop. As the project manager, I will be changing things up a little bit with regards to my expectations for the code. And this is not talking about anyone's actual code. This is just me. I could have written this over the summer. There is some spaghetti code out and about. So we're going to try to create some order out of the chaos of how things have been implemented so far. And the first of those technical requirements, which is why we're going over this, is to go over model view controller. Because you are going to need to refactor all of your CLI code, as well as ensure that the free code that you write adheres to the model view controller pattern. I taught Q12 in both the winter and spring. I actually gave this lecture in the winter, and knowing that I was going to be teaching this class in the fall, I omitted it from the spring because I would just be repeating myself at this point, and I didn't necessarily feel like people would retain that information over the summer, so I opted to focus my attention elsewhere. Now it is time to make sure that we understand it, so that we can immediately apply it to this project, because it's a natural, wonderful application for this idea. Let's talk though about, before we dive into this too much, upcoming schedule, because at least at the start of each week, I want people to be aware of everything that's coming up. So today is the start of Sprint 2. A week from Wednesday is your client demo for this, which means that there aren't too many additional things. I think that Sprint 2 is hopefully going to be a bit easier than Sprint 1. There will be a few extra requirements in the rubric for this, but mostly it's adhering to MVC, a couple other small things. But the big piece of it is getting that GUI up and running. So a week from Wednesday is your client demo. By Thursday, you can expect that you have a study guide for the next quiz that will be a week from Thursday. I think that's it. I have to think about it. Some of us think we're supposed to have a quiz this Thursday, actually. Maybe that is the case. In which case, I will not do that to you because you don't have a study guide. I do not change my process because of that. So even if we have to have some quizzes in faster succession, I will not force that on you quite that quickly. So I'll go back and make sure that I know what I'm doing before. I think that you know what I'm doing more than I know what I'm doing. This isn't going anywhere. MVC. Anyone have any questions or concerns about the upcoming schedule? I think that's basically everything we have going on. Yeah.
There's a big upcoming event today, and it's Fatima's birthday. So are we supposed to sing for that or no?
I think we have to treat everybody in the class fairly. So if we sing for Fatima today, we have to sing for everyone whose birthday happens at any point in the quarter. And I think that's a lot of happy birthday to be singing.
Awesome.
Okay, even if it's gonna take 30 seconds out of just about every class, I will say if we wanna do that, we should do it where absolutely everybody can hear it in the middle of the offices.
I agree.
That's such a great idea. That's an amazing idea. Thanks. Thank you. Thank you, Rob.
All right. Any other questions or concerns that address the whole class? Again, I do want to talk to each group individually. If you're free after class, that'd be great. If not, we can arrange a time. All right, let's dive into MVC. So I know we're putting on pause the last testing lecture that we did. I don't really like to jump around this much, but because it's a requirement for Sprint 2, I feel like it's necessary to talk about now so that you can get started thinking about it and designing it over the next couple of days if you want to. We'll come back to the testing as soon as we're done with this. Also, my life is a stack. So MVC is a classic design pattern. It's not even really considered to be one of the modern design patterns. It's really just an approach that you take. And it's mainly used whenever you have some kind of data-driven application, which means that we are going to be collecting and storing data in some sense. So it's a way to structure your design such that we can collect data, we can listen for events that pertain to gathering that data, querying that data, something that involves manipulating that data, as well as how that data is displayed. So we have a bunch of different tasks that need to be considered. We need to figure out how to store the data, how to load the data into some kind of view, some way to visualize that data. So how do we access storage and modify storage on an as-needed basis? We also need to figure out how do we have a user interface? What do we want in our different user interfaces? As well as we need to figure out how is the user interfacing with that user interface so that we can manipulate it as needed, as well as manipulate the underlying data as needed. You can think of these tasks as reasonably independent of each other. which means that it doesn't necessarily depend on one. The idea that I'd like to have is having a user interface for a mobile site versus a desktop site. Is any of the underlying data actually different between the two ways of accessing that site? And the answer is no, not really. The question is, how are you displaying that data? How you display it changes based on the size of the screen that you have available to you. It may change exactly how you want your layout to be, but the underlying data, the information that's being stored by that site is still the same. So let's actually think about how we're going to do that. So the model is the underlying data representation. So communicating to the data source, storing and retrieving data from the data source. So the model is the communication to the database, or some kind of structure that is storing that data. In our case, we're not really using a database. We're making some data structure that's going to contain all the information that we need that's a part of our UML library. So questions you might ask, or things that might make you think of the model: which database table is the requested data stored in? Which SQL query is going to give me the data that I need? So if you're thinking those kinds of questions, those are questions for the model's design, that the model is going to try to answer. Storage and retrieval of data. The view needs to communicate with the model for what data should I be displaying to the user right now, as well as all of the logic for how is that display going to be handled. Given the data, how do you arrange the data such that it is presented to the user in a user-friendly way? Questions that you might ask or think about when writing view code: would this text look better in different colors, blue or red? Should the text be displayed in the bottom corner or front and center in the middle of the screen? Should these items go in a list or in radio buttons? So all of these are visual designs that use the data in some capacity, which is independent from the actual data that's being stored or accessed. Finally, the controller is all of our listeners. The purpose of the controller is to be the event handler, to say, is the data being changed? Is the user interface being interacted with? If so, does the view or does the model need to update based on the changes that we are determining happened? Better word for that. So if the user clicks on a hide details button, the controller will recognize and see, oh, that button was clicked. I should call some method that's in the view for hiding that data. The user just changed the event details of some calendar or something. I better let the model know that the data has changed, that the event details have changed. So the underlying data about when this event is, where it's happening, something along those lines has changed. So the model needs to know to update that data in the data structure or the database. Does that make sense? The three components and kind of how they're distinguished, or how you can break an application that does all of these things down to those three components. You have the model components, the controller components, and the view components, all separate from each other in ways that they can communicate with each other. But now when you need to go change something about the underlying data, you know that you are working with the model code. You're doing something with the user interface, you're in the view code. You're doing something with the event listeners, you're in the controller code. So some large scale benefits. Your code is organized into the model components, the view components, and the controller components. It's easy to go find what you need if you can just identify which of those three components the change needs to be in. For development, it means that you can more easily split up tasks. You can have one developer working on the model code, one developer working on the view code, one developer working on the controller code. You can write tests for each of these components independently of each other. And then, of course, you get the flexibility of you can design multiple views. So you can easily, at runtime, determine what is this connection type? Is this connection coming from a mobile phone or a desktop? If so, swap out the view, and you can completely change how the user interacts with the entire system by just taking a view object and swapping it out for another view object. You can also swap out models to change how data is stored without affecting the user at all. The user will never know that that happened because no change in the view happens at all. So this is why it's a design pattern. You can design new views without having to go change any of the model or controller code. You can swap out data storage locations or storage structures without changing any of the other code. So if we're talking about this just in theory and not how it actually happens, we have a diagram that looks something like this. The model doesn't really get information from how the user is interacting with it and change. It all happens through a listener. So if the view needs to communicate with the model, it always happens through the controller. But the model can push information directly to the view. And then as the model changes, the controller can notice that something has changed and ask the view, and can notice things happening in the view and inform the model. This is, of course, how things would work ideally. But in practice, a lot of this code ends up intertwined between the view and the controller, because the listeners for that are usually so tightly coupled to the view that it's just easier to write them in the same program, the same files. So the view and controller often intertwined. They almost always occur in some kind of matched pair. When this thing is changed in the view, this is how the view updates. This is how the model updates. There's always that direct pairing. So if you separate those into different classes, it becomes more difficult to, if one's going to be updated, then the other one also needs to be updated. And you don't want there to be two different places where you do it. So it's easier to just do it in a single file where you have those pairs of methods with each other. If you do that, then you get more of a coupled view controller. And the model can push to the view controller, and the view controller can notice some updates and inform the model, and find that there are changes to the model and update itself, the view controller. So you are still adhering to MVC if you pair up the view and controller methods together in the same file. But you'll want those methods to be together so that you have something like what would be an example of that? We're going to listen for the high details from before. And when we have that high details, we're going to go change the view to hide the details. You would have the listen for high details button being pushed method and the high details logic in that view. That would be nice and coupled together. Of course, now if you want to swap out the view, you would have to have that same method for listening for that being pushed or done. But notice that if the view is different, on one case it might be a button being pressed, on another it might come from a menu, or it might come from something else. So it might not be something that works exactly, the listener might not be exactly the same between the two different views, which is why oftentimes you need to couple them together anyway. Does that make sense? I know, horribly boring. Any questions on anything so far? Pretty straightforward. There are two different ways to get information from the model. There's a push architecture and a pull architecture. So we're going to identify this arrow right here and say, how do we implement this feature of MVC. There are two different ways for the view to get updated when data changes. The question is basically, we have a communication. You can imagine that there are two different ways we can hold this class. The push architecture would say something like, when there is an assignment, I will tell you about it. You don't ever need to worry about asking the question, is there an assignment due tomorrow? Because if there is an assignment, I will tell you. The pull architecture says, I'm not going to tell you if there is an assignment, but if you ask me, I will say yes or no. It seems like there's an obvious answer when we phrase this in terms of a classroom. I should obviously tell you when there is an assignment. But there are pros and cons from the design perspective of this architecture when it's a little bit less straightforward. So in the push architecture, when the model changes, it notifies every single view to say, this data has changed, you should update how you display that. You should incorporate that this data has changed. In the pull architecture, a view will have some logic that says, I need to be updated. Maybe this is manually, the user says, refreshes the page. When the user refreshes the page, we're going to pull the latest data from the model so that it's displayed in its newest form. It could be every 30 seconds, there is a direct pull from the model that says, has anything changed in the last 30 seconds? If so, I'll update it. Can anyone think of any advantages or disadvantages for either of these architectures? When would you want to use a push architecture versus a pull architecture? Yeah,
Is it like the observer pattern, like based on how much information you're gonna provide? If you're on the server side and you're gonna have more information, so you don't want to have them come to you, ask for that, you push it to them. And say, okay, this interval, after 15 minutes, I'm gonna give you the information.
yeah,
But if it is only one specific, then that's the type of you're gonna ask them to come and get the information.
yeah, it's very similar to the pros and cons of the observer pattern. So that's a great tie to something hopefully most all of you saw in design patterns at some point, when you covered the observer pattern, was that how do we get notified when the example from, I think that is consistently used is products being stocked. If you want the latest and greatest product, you don't want to go to the store and ask every day, do you have this product in stock? You want to get on some kind of mailing list that says, when you get the product in stock, please notify me so that I can come buy it from you. That's a one-time activity. It's very similar here. The question is just, how many times do we want this connection to be asking for something? Which depends on how vital that data is. How vital is it that we have the latest information right now? So the push architecture, we know we have the latest data. If something goes wrong, or if something is out of sync, or seems out of sync, we know right where the issue is. It's not a syncing issue with the model because we have the latest data. But it requires that that connection be made and that update done every time there's a change. In some applications, that change might be happening multiple times per second, in which case, how much load is there going to be on that? It's going to depend on the technology we're using for that. That's going to use significant system resources. And if that's the case, if everyone in the world tries to utilize that source at the same time, if they're all trying to get those updates, we might put a ton of strain on the server. So we actually get a load question if you're going to implement something like a push architecture. You're not going to be able to handle as many requests as you can if you have a pull architecture. So the pull architecture avoids unnecessary updates. If nothing has changed, then we're not going to ask for it, or something isn't going to change meaningfully within 30 seconds, then don't update within those 30 seconds. If things are going to meaningfully change within the hour, don't update more than once every hour. Maybe then allow the user to make a request for an update, but the automatic update isn't going to happen as frequently. Now you can handle a lot more concurrent requests and a lot more concurrent connections because the traffic between that is not as high. that make sense? Understanding of push versus pull architecture? Why you might want one or the other? You can kind of have a hybrid of them. Push when there's a major change, pull when there's a minor change. That allows the user to request an update. So we're gonna go through a big example here, just to see how intuitive this process is. We're gonna use the example of a traffic signal. We're going to think about what would it be like to write the code for everything with regard to the traffic signal. This is gonna be all of the lights, all of the pedestrian signals, all of the logic for handling the control flow of the traffic in those directions. So here are all of the components to this system. The question that I have for everyone is, does it belong in the model, does it belong in the view, or does it belong in the controller? So I'm gonna let people think about this for a minute or two. Go ahead and write down your answers. And I'm going to query the class to raise their hands when I start going through this. I'm going to write on the board what you think, or if there's some uncertainty between people about where it goes, and that will dictate what kinds of discussions we have about these different components. Go ahead and give that a shot for the next couple minutes. Is it readable to everyone? Not readable to you, there's this entire front row that makes me think that I'm protruding some kind of disgusting odor.
Out of color. It must be what you're wearing.
And I can't wear the same clothes for 2 weeks. Later in the quarter, everyone's gonna be in the last 2 rows, and then by finals, everyone's gonna be in the last row. It's like, can you please just like change your clothes for once this quarter?
In everyone's defense, you do play bad.
That's good.
That felt like personal.
Yeah, good. Hey, I love it. Solid. I've seen.
Please, it's not Yu-Gi-Oh, then I'd be really concerned.
I think we have some answers, or at least some educated guesses.
Yes.
All right. As always, no pressure to be right. Because if you do it all, then why are we here? So detecting cars waiting to enter the intersection. Who thinks this belongs in the model? So raise your hand. All right, we have some people saying it belongs in the model. Who thinks it belongs in the view? Who thinks it belongs in the controller? Interesting. So we're split between these two. So I'm just gonna kind of leave this as a question mark and a question mark. We're gonna discuss this further once we are done. Traffic lights to direct car traffic. Who believes this belongs in the model? All right, the view. The controller. There's at least one person for each. So I'm gonna be, how do I do this? I think we saw 2, 1, and more than that. I'm just gonna kind of write that like this. And again, there is absolutely no reason that says that one of these people is not right. So please do make sure that you raise your hand if that is what you think. If you're the only person in the class who gets it right, you're gonna feel really good. Regulating valid traffic movements. Who thinks that goes in the model? View? The controller? I think we had like 3, 1, and more than that. All right. Did I write it that? Did I get that right? Yeah. Something like that? All right, how about a manual override for particular lights? Does that belong in the model? The view? The controller? All right, looks like we're pretty split between here with one person there. Detecting pedestrians waiting to cross. Is that the model? Is that the view? Is that the controller? All right, we have like 2, 2, and more than that. Pedestrian signals to direct pedestrians. So this is like a crosswalk signals. The model. The view. The controller. All right, it was definitely this. No one said anything else. An external timer which triggers changes at a set interval. Is that the model? A lot of people. Is that the view? Is that the controller? All right, is the notation clear? Because I'm going to reveal the answers and they're going to be overlaid directly on this. So it'll be fun to see who's right and who's wrong, or whether the majority won every single time. I will tell you the majority did not win every single time. Just to add some anticipation. So let's discuss. The key word that tells you that this first one is part of the controller is the word detect. This is a synonym for listen. So the controller is a bunch of event listeners that are waiting for something to happen. When something happens, then something is done to either the view or the model. So for detecting cars waiting to enter the intersection, we would wait until some car pulls up. That detection would happen, we would notify the underlying data and or the view. Is there any view that would matter for? Probably not. So we're gonna be notifying the model that there is now a car waiting to go north-south, or there is now a car waiting to go east-west. With that detection, maybe that changes the underlying model, the data that tells us, should we update the view and change the direction of traffic for the car that is now waiting. So that belongs as part of the controller because it is a listener. It updates the model, and communicates with the model, but it itself is not part of the model. It is an event listener. traffic lights to direct the car traffic. That is part of the view, because it doesn't actually change the underlying data. The data is gonna tell us which direction is active. The lights communicate that to the cars. That is not part of the actual underlying data. You can imagine the underlying data staying exactly the same, but now instead of a traffic light, now instead we have dancing aliens. We have a red dancing alien, a yellow dancing alien, and a green dancing alien. Different view, same data. That's kind of what tells us this. If it's ever the view, just make it something utterly ridiculous, and if nothing else has to change, that's the right answer. I'm a very strange person. Regulating valid traffic movements. These are the underlying laws by which we are going to be affecting the view. So this absolutely belongs in the model because it is the rules, it is the structure of the entirety of the logic for when do lights change. It has nothing to do with listening to tell us that the state is going to change, which is why it's not the controller. I think that's the common misconception between the model and the controller. The controller takes the existing rules and then says, what is it about right now that should change the state of those, the underlying state of the application? Whereas the model is the underlying application. So as part of the rules, belongs in the model. Does that make sense? That was one that a lot of people got wrong. Detecting pedestrians waiting to cross, once again, we have that keyword detect that tells us, it skips the manual override, but detecting pedestrians waiting to cross is certainly the controller. The manual override for particular lights. This is something that someone would have to actually go in and do to change the light structure. So that would have to be an event listener, right? You'd be listening for someone with the appropriate credentials to go do that manual override. The logic for what happens with the manual override would have to be in existence already in order for this override to exist. The rules and logic for that manual override are in the model. But the actual override itself is a listener, waiting for that override. Pedestrian signals to direct the pedestrians. This is the equivalent of the traffic lights for the cars. This just tells pedestrians when to cross and not. This has nothing to do with the rules, it's just the lights. Once again, instead of the red hand and the green person, you could have a red dancing alien, you could have a green dancing alien. It doesn't matter what that looks like. But the fact that it is the signal itself, the design of that signal says that it belongs in the view. We can also have an external timer, triggering changes at a set interval. This one I think might be the hardest one here. So some timer, when it reaches 0, it's gonna send something to the model that says, all right, we need to update. Or send something to the view that says, we need to update the signal. So something like every 30 seconds, we're gonna change the direction of traffic, unless some other rule is in existence. That would be an event listener, waiting for the timer to hit 0. Once the timer hits 0, the signal would be sent to the views, turn that green light yellow, turn that green person into a red hand, flash it for a bit, hit red, switch the direction of traffic. That is an event listener waiting for that timer to hit 0. So it's part of the controller. The rules behind how long does that external timer last? That is part of the model. So the rules governing the timer are the data. Does that make sense, how the distinction between them? I feel like the view is usually pretty easy. And model versus controller is where people start to have questions. Another way to think about it is it more coupled to the view or is it more coupled to the model? So detecting cars waiting to enter the intersection is more coupled to the view because you need a camera to recognize that is happening. It interfaces with the system right now. Any questions on why any of these are the way they are? This would be a great time to clarify that. Yes,
So basically the manual override for the particular lights, that's controlled because they have a view of. Someone in the audience would have to see it and then change it, or what was the reason?
yeah, so I'm imagining a manual override can either be something that's triggered remotely, digitally, or someone who's actually at that system who has access to some electronic, enter your password, do something, change something directly on site. But I'm more so imagining it as something, this is a remote system, you can log into that remote system, the appropriate credentials, you could change how things work. Maybe changing this light into flashing yellow lights, for instance, that say, treat this now as a. You can go one way, it's a stop sign the other way, or flashing red lights that say this intersection is now a stop sign.
So would it kind of be like the button on crosswalk, you press the button, the lights start flashing?
It would be, I log in, I type in my password, I select that manual override for flash everything like it's a stop sign, go. Then that's an event listener that would be waiting for a credentialed. Where I'm looking for, so some kind of credentialed signal to be sent to allow for this logic to be run. So it'd be a listener for that logic. And then the view would get updated, so the lights don't do what they usually do, they would be flashing red now. The model would be updated to turn off this timer. That switches the direction of traffic, et cetera. It's a great question and a great clarification. Does that make sense to everybody, so as to why that is? So we did good, but there definitely is something to learn here still. Which is why we talk about it, especially if you're gonna be applying this concept to your project. You will want to be asking yourself very similar questions to these kinds of questions with regards to your HTML editor. When is a particular, these are very much like tasks. You can see this on a Kanban board or a GitHub issue tracker. Something that says, this is something that we need to implement for this next sprint of designing an application that handles a traffic signal. Each of these tasks should either go in the model code, in the view code, or the controller code. And you want everybody to be on the same page about where that code goes, so that you don't create a bunch of spaghetti code where you're sending information from this class to that class to some other class to some other class, back to the first class, over to the fifth class, in order to get something done. You don't want to pass information that many times. You should either be communicating from the model to the controller, from the view to the controller, to something that is within this system. So you want to make sure that that is in the right place. Bigger eraser, wasting time. So fun though. All right, to kind of summarize where everything goes. In our traffic signal application, the model is the state of traffic flow, so which direction of traffic is currently green, which direction of traffic is currently red. It is also has the associated code to skip a light cycle. For instance, if there is no car waiting east-west, maybe north-south is the main flow of traffic. If there's no car waiting east-west, don't trigger the east-west green and make the cars that are currently flowing north-south stop for nobody. If anyone has experienced that, it's infuriating, isn't it? When you see your light turn red, no one goes in the cross traffic, you sit there waiting before you can go. It feels like something should be doable about this. There's logic in traffic signals. Some of them are dumber than others. Some cities are full of dumb traffic signals. My own experience in Billings, that city is full of the dumbest traffic lights I have ever seen.
Which does suck.
I got stuck at an intersection in the middle of the night for about 8 minutes. I was just curious. I could just go, and then after about 5 minutes, all right, how long are you going to make me wait here?
Have you ever gotten to that point where it's like you've been waiting so long that you just get out of your car, press the pedestrian button?
Because then it makes it legal, right? If you go, there's just no one coming, it's illegal, but if you get out of your car, press the pedestrian signal, I'm here, let me go. I probably should have done that in Billings, but yeah, Billings has a number of lights like that that are just infuriating. Luckily, Spokane's lights are actually pretty intelligent.
I
You
actually.
just have to be patient.
Yeah, we don't talk about the vision.
I would love to go more than like 2 lights without having to stop for 5 minutes. It would be so exciting.
Or you just take a right and then you go straight, or you
It's
go right.
really interesting when you think about it as a 2D grid. I know we only have a couple minutes, but we also only have 1 slide left, so I feel a little bit okay on this tangent, but. Draw this out for yourself at home if you're really interested in traffic flow theory, because it's actually really interesting. Draw yourself a 2-dimensional grid that represents, any West Coast city that actually has a grid. If you're in an East Coast city that isn't a grid, good luck. You're just screwed. But a reasonable West Coast city is going to have an adequate grid. If you can try to maximize flow one direction and then realize the constraints that it puts in the cross-directional traffic, it makes it really interesting. Think about coming up with a single way, like if I were trying to circumnavigate this entire grid in some way, shape, or form, what rules could I place on these lights to minimize the total time that it would take to traverse that grid? Play around with it, maybe we'll come back to it later this quarter, it's something that I've thought about a little bit. But it makes for a very interesting exploration into optimizing systems like this. And if you have a lot of fun with that, you should go into city planning, we desperately need logical city planners.
Okay, short anecdote, as a kid for like my school's science program, we got to actually go to the Spokane Traffic Control Center.
Yeah,
Where a lady showed us, oh, here's like the timer used for these lights and it's generated this value, so it doesn't cause issues like this. She then changed the value and I got to see cars stack up and wait for about 5 minutes before they could find them.
what's interesting about the real world is even if you optimize for this in the short term, what happens at rush hour? There are different demands for east-west traffic, north-south traffic, depending on the time of day. So now the question is, how does that optimal system change when the system modifies itself slightly? Can you automate that process? Can you use data that you could collect in real time to optimize that system?
I told you this earlier, but it's applicable now. But I was playing Frostpunk and I believe that all cities just start like this and then they just get a huge mess and you're like, well, it's too late to break everything and fix it now.
Right, but even with the suboptimal layout, there's still, given that, an optimal algorithm for optimizing traffic right now. Maybe it's wrong in 5 minutes, but what kinds of data could you collect to be able to make an informed decision about how should we be regulating our lights to minimize that traffic? Minimize the total cumulative amount of sitting on your ass doing nothing in your car.
I wanna find whoever wrote that program.
Yeah. But that's a reasonable optimization program. That sounds like fun. City planning might be for you. Diving into the code, just with our last minute here, the model would consist of something like a single class. We'll call it traffic model. The contents of that keeps track of which lights should be on, which lights should be off. The logic behind how lights change. That is the data. Which lights are on, which lights are off, what changes, the associated rules of which that change happens. The view would have 2 classes, the car light and the pedestrian light. That just is a snapshot of the state of the model. So the model says which lights should be on and off, but the view actually displays that information to the end user. Finally, the controller would contain the pedestrian button that would notify the model that there's a pedestrian waiting to cross a particular crosswalk. A car detector that when that triggers, it notifies the model that there is some car waiting at one of the red lights. A light switch would enable or disable the light completely. something like this is on, this is off. Or maybe this is on, this is treated as a stop sign, this is treated as one of the different ways that a light could operate. And a timer, it would also be in the controller regulating some way how to switch the cycle, when to notify the model to switch which light is green, which light is red. Waiting for that timer to hit 0 to send the message to the model, switch. Reset the timer. Or if the timer hits 0 and there's nothing waiting, don't send that signal, don't switch. Questions on anything from MVC? All right, we are out of time. As I mentioned before, I'd like to meet with teams if you have availability and would like to provide any feedback about how the spring went. I just would like to hear that from your perspective, just to get a better understanding and idea. I spent a lot of time and effort over the summer trying to optimize this class to minimize the headaches. So I need to know which headaches still exist so that I can continue to do that process. What should I be considering the next time I go through and try to optimize this class? So let me know. And we'll move forward with sprint 2, where your code will need to adhere to model view controller. Tomorrow, we're testing.